who was Bella in Twilight. And so machine learning really is for everybody today. At Amazon, we have thousands of engineers focused on machine learning and artificial intelligence. And we use it routinely and robustly just as a natural order of doing business across Amazon, whether it is fulfillment and logistics, so our robotic systems that allow us to move inventory more efficiently around our own fulfillment centers, or our computer vision systems that allow us to onboard more new inventory into fulfillment centers more quickly. All of that is powered by machine learning running on AWS. We use it for search and discovery on our retail store website. So searching ahead, customers who bought this also bought, recommendations, customer review summarization, all of that is powered through machine learning. We use it extensively to improve existing products. So if you have a Kindle, you can use a feature called X-ray, which allows you to look inside the book that you're reading, identify the characters and the themes, and see how those characters and themes interact through the course of the book. If you're watching a movie on Fire TV or on a Fire tablet, just hit pause and we'll drop you into X-ray for video, which allows you to identify which actor and actresses appear in which scene, along with which music is playing, and where you can purchase that soundtrack album. Finally, we use it to define entirely new categories of products. Most recently, this includes Amazon Echo, which runs Alexa, the digital personal assistant from Amazon. Alexa is a natural language understanding and speech recognition service which runs up on AWS to allow you to set timers, ask questions, get the latest weather, or control connected devices inside your smart home. We also recently announced Amazon Go, a no-lines, no-checkout convenience store which is currently in beta for staff here in Seattle in Washington. This is one of the perks of being a member of Amazon. This is where I get to go for lunch pretty much every day. Amazon Go allows you to walk in, flip your phone at a turnstile, then walk around and pick up everything from pastries to sandwiches, drinks, beer, and wine, and then just walk out, and we build your Amazon account a couple of minutes later. And this is a sensor fusion and deep learning computer vision powered system running up on AWS. So all of these examples, they may sound futuristic, but they're here running live in real life today up in the cloud. And this is one of my favorite quotes. The future is here, it's just not evenly distributed yet. Our approach at AWS has always been to take technology that was traditionally out of reach of most developers and only within reach of large, well-funded technical organizations, and then take that technology and make it available to everybody. Enterprise developers all the way through to startups that were just getting started in their own garage. And we've done this successfully with storage and compute and databases and data warehousing and analytics. We want to take the exact same approach and make machine learning as evenly distributed as possible so that everyone can take advantage of this magical technology. Our general approach is that we want to enable our customers to build intelligent systems that run up in the cloud and increasingly run at the edge, even in disconnected environments. So we are seeing a big trend with customers who are using services such as SageMaker up on AWS to train their models using the data that they've collected, and then they're running inference on those models up in the cloud. This allows you to run sophisticated models in the cloud where you have as much capability, as much power as you need. Increasingly, the additional trend is that customers are taking smaller subsets of those models and embedding them inside mobile devices and edge devices, everything from tablets through to autonomous cars. And we call this inference captured at the edge, either because you want that device to run in a disconnected environment or because the volumes of data are just so large that you can't afford the round trip back to the cloud. So we're making significant investments across SageMaker, across Greengrass, across DeepLens to enable our customers to take sophisticated models and run them both in the cloud and at the edge. And with that, I'd like to hand it back to Craig. Thanks a lot.
Let's look at some of the exciting ways that our customers are changing what's possible and unlocking new todays.
So I'm Nung Ho. I'm head of data science for Intuit QuickBooks. And Intuit is a leading financial services company with a mission to power prosperity around the world. We have about 8,300 employees spread over 11 countries, and we're currently headquartered in Mountain View, California. So we've been on an AWS journey since 2013, beginning with the migration of our application services to AWS, and now moving our data to AWS. The next step in that evolution is what you do with the data, and that's where we're shifting and migrating to use a SageMaker specifically. So we're leveraging SageMaker for both services, pairing the data that already is migrated to AWS with the SageMaker model training services, and then moving to model deployment so that our applications can consume those models in real time. So when you think about the entire model development lifecycle, from hypothesis generation to building the model to training the model to then deploying it, previously 90% of my time was spent on the model deployment. But now, by using AWS services, 90% of my time is in model development, and the rest of my time is spent on deployment. Part of Smart Products is a product that knows you intimately, that knows your financial well-being, that actually can tune itself to your needs at the right time, right? So there's a who, what, where, and when component. So when we talk about Smart Products, we want to encompass all three of those facets. So personalization is definitely core to that. And again, in order to personalize our products, we need to be able to rapidly test brand new solutions as quickly as possible. Our three customer promises: more money, no work, and complete confidence. And machine learning can deliver individually on one of those along different facets. But our ultimate goal is to really embed AI and ML in our products across the board and build a financial AI that can take care of your finance, help you save money so that you can plan for your future and not have to worry about how much money is in my bank account today, right? Having that full confidence to say, I actually have the money to be able to grow my business, and I'm confident that I can do that because Intuit has my back and is taking care of my finances so that I don't have to worry about it. Due to the data that our customers trust us with, Intuit is in an unrivaled position to leverage AI and ML across our products, including QuickBooks, TurboTax, and Mint. We can use this predictive intelligence to make our products smarter, automate repetitive tasks, and personalize it so that it takes care of our customers' entire financial lives. My name is Nung Ho, data scientist at Intuit. Hope you had a great time and enjoy the rest of the sessions.
Hi, I'm Swapan Rajdev. I'm the CTO and co-founder of Haptic. Haptic is a company that specializes in building chatbots. Our goal is to power and build great chatbots everywhere. And we do this by building a platform on top of cutting-edge machine learning and NLP technologies. So when we were starting Haptic in 2013, we were evaluating multiple different options on where to host our servers and how we can get a platform that can help us scale along with be able to be flexible. As a company, we truly believe in speed of iteration and trying new things. AWS has really allowed us to focus on our core expertise, which is building our product and building great chatbots without having to worry about the scale and the infrastructure underneath. We grew 30% month over month, and never once did we have to worry about how we will scale our compute power or the infrastructure below that. Apart from just scaling, AWS has a wide range of services which has always had a solution for every single feature we were trying to build. We use multiple different services provided by AWS, and every single feature of that is powered by AWS. All of this actually comes at a very great cost, and we've been able to scale from a small business to a big-sized business without having to worry cost on our infrastructure. As time went on, we started realizing the power of different services that AWS provides. So every single solution while we were looking at, we realized that AWS had a managed hosted service which would help us to be carefree about scalability, and we could just go and deploy them in very short time. And that's the reason we started realizing that AWS is a very powerful platform, and 5 years down the line, we're still very much on AWS as a platform for multiple different services across the board. From the beginning, we knew machine learning is going to have a crucial part in how we build and scale Haptic. So we started investing in machine learning from day one. Today, we have multiple workloads that run in production, having multiple ranges of algorithms from supervised to unsupervised to deep learning algorithms. In the past, we've had to use multiple GPU instances that AWS provides to be able to train and tag different sorts of data. A great user experience at Haptic is when we are able to provide answers to users in less than 2 seconds. And AWS and EC2 has helped us tremendously in achieving our goal without having to worry about the scale. Building a good chatbot and providing a good user experience is the DNA of Haptic. On a daily basis, we try to make our chatbots smarter and broaden our reach so that we can help multiple different clients solve problems using chatbots. We already use Amazon Poly to power one of the most popular features at Haptic, which is reminders. Moving forward, with all the new features and understanding that we're trying to build, we're actually evaluating multiple different services to see if we can get SageMaker to work in conjunction with our algorithms to make a lot more better, smarter bots. Along with technology, AWS has really helped us with marketing, brand building, and acquiring new customers. As leaders in the chatbot space, AWS is helping us lead this paradigm shift.
My name is Adrian Letchford, and my role is the Senior Data Scientist here at Airtasker, and I figure out how to solve problems using machine learning. Now, my main focus is on operational problems. So how, as a company, can we do a better job using machine learning? Airtasker gets things done, right? So we provide a marketplace where people with work that needs to be done get connected to people who want to do work on their own terms and money on their own terms. We've been around for about 6 years. We're based here in Sydney. We employ about 140 people, and we're spread across Sydney, Manila, and London. Back in the day, Airtasker was running on 4 servers that are less powerful than your laptop. Right, now the problem here is we're growing really fast, and they cannot keep up with this growth. So anybody working in the industry really knows that your environment needs to enable your growth, not block it. And that's why we turn to AWS Cloud. Any of the cloud providers, they all provide pretty much the same thing, right? Everyone gives you unlimited computing power, unlimited storage or elastic services. The real cloud race is who has the best services. And for us, we find Amazon really does have the best services. It really comes down to scale. So as we're growing, we're getting more and more and more customers, and we can't manually look after them ourselves. We can't do everything that needs to be done. So a lot of our performance gains at Airtasker with machine learning revolves around all the content people are posting. So someone's got to sit down in front of the screen and do all this by themselves. And our machine learning algorithms, they come in and take over. And every time somebody posts something, the machine learning algorithms scan it and makes really quick decisions. Things like, is this illegal? Should this be taken off? How much it should be insured for? If it's a comment, are they bullying someone? Right? And all these decisions are being made at lightning speed. And we're managing to pass through a marketplace that's serving 26,000 new jobs per week and over 40,000 comments every single day. At Airtasker, we're using Amazon recognition every time someone uploads a photo. So once a photo gets uploaded, recognition passes through this, gives us a feature vector, tells us everything we need to know about the photo. It could be, say, a website mock-up that somebody's done, and it tells us this. It could be a photo of someone's backyard, a photo of a hole in the wall. We find out all this information about the photos, and then we put this into our predictive algorithms that tries to figure out, is this safe, is this bad? So AWS has really allowed us to move really quickly. If I want to deploy a machine learning model, a really simple one, I can do that straight away. If I need to fire up an array of GPUs, I can do that immediately. If we want to process something in minutes rather than days, we can do that as well. All of this power that AWS gives us is fantastic, and we're able to then, instead of worrying about our infrastructure, focus on delivering solutions for our customers. AWS really stands out from other providers for us. So technically, they deliver what's promised, which is fantastic, but it's the way that they deliver it, which is really amazing. So we're able to have really tiny, fine-grained control over all the little details. And this means we're not just software engineers, but we're engineering our own infrastructure. So for us, we believe that Airtasker should be like electricity. It should be always there, always available, and ready when we need it. AWS has the best technology at a commoditized price, and we really can build anything.
We've heard from Dr. Matt Wood on how and why AWS is building what we're building, and I look forward to what the future of AI might look like. We've also seen the impact of machine learning through the eyes of our customers. So now let's talk about how you can start building with machine learning and AI using AWS. The world we live in is becoming increasingly connected. The people, the devices we hold, the vehicles we drive, the buildings we work in, the cameras that are on those buildings. Much of this data is arriving in streams, and increasingly we want to process it in real time. To really understand the context of all this data from all of these connected systems, we see deep learning being an enabler for AI systems. And so we think about machine learning at a high level of having 3 layers of the stack. The bottom layer is for expert machine learning practitioners. And these are people who are comfortable building models, tuning models, training models, figuring out how to deploy in production and manage them themselves. And the vast majority of machine learning and deep learning being done in the cloud today, at this bottom layer, is being done on AWS, on our P2 and now P3 instances, which are the most powerful GPU instances in the market today. And then using our deep learning AMI that we built that effectively embeds all the major frameworks. But we have a little bit different approach at this bottom layer of the stack than the other providers. We're not going to try to tell you that you should try to solve all your machine learning and deep learning problems with one framework. Well, today, TensorFlow has the most resonance, and there's more TensorFlow being run on AWS than anywhere else. If you're trying to build a computer vision model, it turns out that Caffe 2 is often the best choice. Or if you're trying to build a recommendation system or doing image or video analysis or natural language processing, it turns out that MXNet scales the best. We'll support them all. In the middle of the stack, there are lots of solutions, but none of them have been easy enough for everyday developers. You need to first figure out how to aggregate all your data, and you've got to figure out some way to visualize and explore your data so you know what algorithms might be worth training. You've got to figure out how to pre-process that data so the algorithms can do their work. Then you have to build. You've got to choose which algorithm and framework you want, and then once you choose an algorithm, you have to train the data. Then you have to tune it and tune the parameters so you have a usable model. There are thousands, and in some cases, in the largest models, millions of parameters that you have to tune. After, you have to figure out how to deploy that model into production in a reliable way, which is a different set of computer science skills. Finally, you have to figure out how to manage that at scale and run the infrastructure. That's a lot of challenges just to build machine learning. And what happens is that everyday developers just throw up their hands in frustration. We want to enable any developer or company to have access to the same selection of services, the same cost structure, and the same scalability as the largest companies in the world. We want everyday developers and scientists to be able to use machine learning much more expansively. So with that in mind, we've released Amazon SageMaker, which is an easy way to build, train, and deploy machine learning models for everyday developers. So let's look at these blockers I talked about earlier and look how they're different now. First, build. Right from the get-go, with one click, you get a managed hosted notebook that uses the popular open-source Jupyter framework. You can use one of our pre-built ones that are optimized for your cases or import your own. We've taken the top 10 commonly used algorithms, and these are things like k-means clustering for data segmentation, or you can use factorization machines for recommendations, or time series forecasting, or XGBoost, the top 10 of them. Now, if you don't want to use our SageMaker algorithms, you can choose to specify the framework you want to bring in the algorithm you want to bring with it. And we've done a ton of work over the last year natively optimizing TensorFlow and MXNet. So again, you don't have to worry about any of those behind-the-scenes setting up of frameworks and so on. That's all taken care of natively for you in SageMaker. Now, train. It sets up auto-scaling, all the EBS volumes, the data pipelines, and starts training, either with the SageMaker algorithms or the TensorFlow and MXNet scripts or whatever algorithms you bring to bear. And when you're done, SageMaker tears down the cluster. No longer do you need a separate team to manage the training. There's really 2 main things you have to do when you're tuning. One, do I change the data that I'm ingesting in the model? And the second is, how do I actually tune the parameters, or what people call hyperparameters? So what we've done in SageMaker is we built a feature called hyperparameter optimization, or HPO. And so, with hyperparameter optimization, you can check a box at the beginning of tuning, and it will do the HPO for you. Finally, deploy. And then when you want to actually deploy the model to production, all you do is you pick the instance you want, number of instances, and you one-click your model to production. And SageMaker will deploy it across multiple availability zones. It will set up auto-scaling for it. It will set up a secure endpoint so they can easily connect to your application. That's all you have to do. There's no other solution out there that lets you do close to this easy a deployment to production. SageMaker manages the compute infrastructure on your behalf. It not only does the auto-scaling, but performs regular health checks and handles node failures under the covers and applies security patches, does all kinds of routine maintenance. So, can we do more to put ML in the hands of all developers? Well, we introduced AWS Deep Lens, which is the world's first wireless deep learning-enabled video camera for developers. This high-definition camera with onboard compute is optimized for deep learning, and it comes with computer vision models that we've already built so that you can use right away on the camera. Or you can build your own in SageMaker and import them over the air via the console with a few clicks to Deep Lens. It has Greengrass in it, so in addition to writing the models, you can program Greengrass to run various Lambda triggers. There's lots of tutorials and pre-built models for you so you can get started right away. We think you can build your first use case in as little as 10 minutes. Now, we've invested in building machine learning for our businesses and have learned a lot during that process. At the same time, we recognize that a lot of our customers want to be better with ML, but lack the required expertise and skill set. It keeps them back from being able to experiment and innovate in the ways that they'd like to. So Amazon has introduced the Amazon ML Lab, which provides the expertise that many organizations lack. Customers can leverage Amazon experts with decades of ML experience gained from building for Amazon Echo, Amazon Alexa, Prime Air, and Amazon Go. We provide opportunities for brainstorming for new ideas, helping with the analytic modeling, and providing training for organizations to ramp up to take on these challenges on their own. So far, we've talked about the bottom and middle layers of that machine learning stack. Now let's talk about the top layer, which we call application services. Previously, we launched a text-to-speech service called Polly. Polly now supports 52 voices across 25 languages, supports custom vocabularies, and includes lip syncing and text highlighting. And we launched a conversational app called Lex, which is really all of the natural language understanding and automatic speech recognition in Alexa wrapped up into a service called Lex. And then we also launched an object recognition service called Recognition. So customers are able to add image analysis to their applications. So you can ask questions like, show me a picture of where there's a woman driving. Or you can ask a question like, is the person driving smiling or frowning? So in addition to object recognition and facial recognition, the service is also able to recognize inappropriate content. It's able to do celebrity recognition. You can look at words and street signs or in advertisements like Pinterest is using us to do. Now, with video, you've got to deal with time and motion, and very often, you need the context of the frames before and the frames after to really know what you're capturing. So it's not a simple problem. We've been working on this for a while and have introduced a new service called Amazon Recognition Video, which does real-time and batch video analytics. We detect objects and faces and scenes, like a package being delivered, which is useful for a lot of different apps. It has many of the same capabilities as recognition image. So that's the vision part of those application services. How about language? There are so many other things that builders want to do with language. And one of the things that's been interesting is that there's so much data that's now locked up in audio and video files. We've introduced 3 new services. The first is Amazon Transcribe, which does automatic conversion of speech into accurate, grammatically correct text. So Transcribe does long-form automatic speech recognition. It can analyze any WAV or MP3 audio file and return text. It's super useful for all kinds of things, like call logs and subtitles for videos or capturing what's said in a presentation or a meeting. Another new service is Amazon Translate, which provides natural and fluent language translation. So Translate is great for use cases that require real-time translation. These are things like live customer support or business communications with social media. You'll see in the coming weeks, we're going to be able to recognize the source language on the fly, so you don't even have to specify what language you're trying to translate from. The third new service is Amazon Comprehend, which is a fully managed natural language processing service. And Comprehend uses natural language processing to give you highly accurate information about what it contains in 4 categories. 1, entities, which are really people and places, and dates, brands, and quantities. 2, key phrases that add significance to the language. 3, what language is being used, and 4, sentiment, whether or not people feel positively or negatively about that content. Now, these are the 3 layers of the stack to build ML using AWS: frameworks and interfaces, platform services, and application services. So what's required to have the broadest and easiest to use machine learning platform with the most number of customers that want to use? If you don't have the right foundation, it really doesn't matter what your machine learning services are. And it means that you have to have a fully featured data lake like we have in S3. It also means that you need to have all kinds of security and access control capabilities, because a lot of the data that you're going to end up using is your crown jewel. And you need to have the right compute and GPUs, the broad array of analytics services that you're going to work with to to make sure that you're using your machine learning effectively. Then, when you have that foundation, you can layer on top of that deep investment in each of those 3 layers of the stack. It's making it so much easier and accessible for everyday developers and scientists to be able to actually engage in and get value out of and use machine learning. It's why we have the broadest and most capable machine learning platform and why you see the most number of customers who are using AWS for machine learning. We have put together 6 tracks for you today with lots of sessions that we hope you find as exciting as we do. We have track 1 for business users that want to understand how to select the right technologies and apply them to their business. Track 2 for IT professionals who wanted to dive deep on fully managed application services. Tracks 3 and 4 for scientists and analysts who want to learn more about ML algorithms and techniques. Track 5 for customer engagement platforms. We also have a live demo track, and for our Korean audience, a full track for you too. Please join us through the day, and we'll have a closing session with live demos from our always entertaining and thought-provoking solution architects, Glenn, Olivier, and Adam. Thank you and enjoy AWS Innovate.